And there'll be a link to my YouTube page where you can watch the video. Or to review for a test, that's a good way to review for a test. Go watch all the videos from that unit. Good idea. Okay, 2 variable inequalities. Our essential question today is, how do the inequality symbols affect the line of the graph? How do the inequality symbols affect the line of the graph? Also, how do you, oops, I forgot the U. How do you determine where to shade? Okay, and for those guys who are new, at the end of your notes, you're supposed to write a summary. And the first sentences of the summary answer these questions we write at the top. Okay, so when you're answering questions, you restate the question. So it should be a paragraph at the end of all your notes. You should write a summary. All right, we're going to do 2 problems. And for these 2 problems, everyone will need rulers and a bag of crayons. Oh, can you pass those back, please? Yeah. Yeah, mathexcelforschool.com. Use Firefox. No. Okay, pass the rulers back, please. Really, you only need 1 crayon, so I'll give you a baggie and you pick your color. Okay, pass those back. The directions for both of the examples we'll be doing is to graph. Okay, example 1. We're going to graph. By the way, what is inequality? I've written the word inequality twice. Who can tell me what inequality is? Inequality. It's kind of like equal, but it says in equal. Inequality. Okay, Phoenix?
Greater than or less than?
Yeah, right? Greater than is saying it could be a large quantity of numbers would be greater than this piece. So with inequality, there's not one solution. There's multiple solutions, either greater than a certain point, less than a certain point, or it could be equal. So which symbol is this? Greater than or equal to. Remember, if it looks like an L, like this, you can write ESS and it looks like the word less, that's less than. So that's how I remember. If it looks like an L, it's less than. If it's not an L, it's greater than. Jared, that needs to come out of your ear. Thank you. All right, here's our inequality. Y is greater than or equal to negative 2x plus 1. And we're going to graph that. Y is greater than or equal to negative 2x plus 1. There's different ways we can go about graphing. We could get an XY table and get a bunch of points, or we'll go join them and sign up for it. Pretty sure you did, though, because you were here at the beginning of class last time. Okay. Or we could do a table of values, or if you remember slope-intercept form from, I'm guessing, 9th grade, you learned that? mx plus b? You've seen that before, right? Yep. Susanna, do you remember what the m stands for? Do you remember what the b stands for? Huh? Kelsey, what does the m stand for? Oh, lots of people have kind of whispered it. It's been whispered through the room. Cynthia, what does the M stand for? Ah, there you go, slope. And we have a phrase for slope. Rise over run. Good. Okay. What is the... Good job, Hakeem. Y-intercept. That is where the graph crosses the y-axis.
Do I have to take notes now?
Yes, you do. So here we see slope and y-intercept immediately because it's in order in slope-intercept form, but in inequality. Okay, so here's our slope. But if I wanted to see rise over run, what number would I put underneath -2? It still has to be equal to -2, though. Well, -2 divided by 2, is that still -2? No. -2 divided by what number will still keep its value -2? -2 divided by 4, is that -2?
1.
Ah, if we put a 1 underneath it, would it keep it at dividing by 1 still makes it -2, right? So this is our slope. And this is our y-intercept, or b. Okay, so we're going to graph this. If you notice, our y-intercept is 1, so that's the center point on our graph that we'll start with. So we want to situate our graph so that we can actually see the number 1, and then we can get a few higher than it and a few lower than it. So I think -5 to +5 would work out fine. We're only going to do 2 graphs, and you have the whole page to do 2 graphs. So don't make these itty-bitty. Make them large enough that you have room to see what's going on. I think I want to move this down a little bit. Oops, not the whole thing. The whole thing down. Here we go. It's not liking me right now. Goodness. Okay. Okay, set up your graphs. You have your rulers. Make sure you label your x and y axes. There we go. I like that better. Part of the labeling is putting number values with your tick marks. 1, 2, 3, 4, 5, -5. Try to evenly space them. That's important on graphs, is evenly spacing. Okay, have you done this before? Yeah. Evenly space them, label x and y, and number your axes. Okay, is everyone ready? The first point we need to put on is the y-intercept. That's the starting point. Okay, Carlos, let's go Carlos Jimenez. Which value was the y-intercept again? B, which is 1. So on the y-axis, put a point at +1. From that point, you use the slope. Rise over run. Hey, what does it mean to rise -2? Does not, actually. It's kind of confusing. It says rise, but it's negative, so that means you go down 2. We ride the elevator down 2, and then we run to the right 1. We need to keep that going. We're going to get lots of points all the way through the whole graph. So we'd go again, down 2, right 1. Down 2, right 1. When did you come back?
I already have one, so.
I thought you did.
Yeah.
You need to get caught up on your notes.
Right here.
No. If you need more paper, well, it looks like all my paper's gone. Okay, we go up to left 1 to stretch it out into the top quadrant there. 8, 4, 1, 2, 1. Up to left 1. Now, don't draw a line through it. If you remember from one-dimensional inequalities that you did last year, there are 2 different types of things we put on inequalities. On one-dimensional, when you're just graphing on a number line, you either put an open circle or a filled-in circle. Open circle or filled-in circle, depending on what the sign is. Which one needs to be filled in? Point up if you think it's the top one, or down if you think it's the bottom one. Which one needs to be filled in? The top one, point up, or the bottom one, point down? Which one needs to be filled in? Thanks for showing me. Show me which one needs to be filled in. If you don't know, you have a 50-50 shot to get it right. Good, the bottom one. Extra line means extra fill. That's when we're graphing one-dimensionally on a number line. Okay, but now we have 2 number lines. We have an x and a y. So through these points, you can tell that they're linear. Either we're going to graph a solid line or a dotted line. So the solid would be the same with here. Extra fill means solid line. No equal to, no fill. That's going to be the dashed. Dashed versus solid. Could you write out this key, please, on your paper? It's important to know when you do a solid line and when you do a dashed line. And it all depends on the sign. So let's look at the sign. And I'd like you to show me. For a solid, we do it like this, but don't do it high. Okay, we're not doing Hitler stuff. Solid, okay? And this is dashed. Okay? So please show me. Take a look at the sign. Match it up with the key. The inequality sign, match it up with the key. Solid or dashed? Which one is it going to be? Solid or dashed? Show me, please. Solid or dashed? Good. Well, it can't be both. It's either solid like this or dashed like this, okay? All right, so solid. Now take your ruler and draw a solid line through those points that you've graphed. And the graph is our answer, so there's one more thing we have to put on our answer, and that's shading. Because when we were talking about greater than 4, who can give me a number greater than, say, 4? 5. Is there another number greater than 4? 6. Is there another number greater than 4? 8. So what you're telling me is there's lots of numbers greater than 4, right? There's infinitely many. Same here. There's infinitely many solutions. So we show our solutions with shading. That's why I gave you the crayons. So we have to, in order to find out where the graph needs to be shaded, we have to pick a test point. The most convenient test point to pick is 0, 0. But you want to pick a point that's not on the line or even close to the line in case you accidentally squiggled your line and accidentally drew your line around a number that should have been graphed. So we want to pick a point that's not next to the line. So 0, 0 is a little too close. So the next most convenient points to pick are points on the y-axis. Because if you pick a point on the y-axis, what's the x value always going to be? 0. Do you agree? If you're on the y-axis, your x value is always 0. It's really nice when you have zeros because then things cancel out. Okay, so pick a point for us that's not on the line, that's on the y-axis. 0, negative 1. Is this point right here away from the line? Would that work? It is. It's still kind of close, but it would work. Okay, so that's going to be our test point. 0, negative 1. Now the 0 and the negative 1 stand for something. Shay, do you know what the 0 is representing? The other one. So it would be the, yeah. That's the x-coordinate. So the negative 1 would represent the, y-coordinate. Okay, so I'm going to rewrite our inequality, negative 2x plus 1, so I can see it. And now we're going to replace the x's and y's with our numbers here, 0, negative 1. We're trying to determine if this point is true or false. Okay, so instead of y, we're going to plug in what number from our test point? Negative 1. It's greater than or equal to negative 2 times whatever x was. What was x on our test point? 0 plus 1. So anyone have questions how we came up with this or why we're doing this? To figure out where to shade. Okay, so the reason we chose one with a 0 is because look what happens. Negative 2 times 0 cancels out. And that would happen a lot if we use 0, which is convenient. So we need to determine if this is true or false. In sign language, this is a T. Everyone see? T. You put your thumb inside your second and third finger. And this says the OK sign is false. F for false. Okay, true or false? Show me. Is this true or false? Negative 1 is greater than or equal to positive 1. True or false? True or false? Is negative 1 greater than or equal to positive 1? True or false? Junior, what do you think? Negative 1 is greater than positive 1. Think about it. Is a negative greater than a positive? So owing money to the mafia is better than having money in your own bank account. Okay, that analogy didn't really make sense. Okay, Sean, true or false? False. This is false. Therefore, the point we chose on the graph is false. Okay, this guy is false, which means every point on the same side of it is false. So where's the true section? Up, right. Okay, pick a crayon. We're going to shade the true section. You only shade where it's true. Where it is true is everything to the right. We could pick any point in this area and it would always come out true. Versus the other side, any point we picked on the other side would always come out false. Like we just talked about, there's infinitely many numbers greater than 4. So we can't just shade one point that's true. Because any point in this yellow area and beyond, because our paper, at some point we're going to run off the page, any point in this area is true. Makes the solution true. Or it's a true solution, I guess I should say. Does that make sense? So the graph with the solid line and the shading is the answer. Tristan, do you have that? Okay, one more, and then we'll be done. Same directions, we're going to graph. Example 2. Y minus 4 is, what's the symbol?
Less than.
Less than, because it looks like an L. to absolute value x minus 1 absolute value. Make your absolute values nice and long and tall so it doesn't look like an 11 at the end. Okay. Is this one ready to get points and see the slope and the y-intercept? Okay. Who can tell me what's wrong with it? Parker, can you tell me?
Y is not alone.
Y is not by itself. Jared, how can we get y by itself?
Do the inverse operations.
Such as?
Instead of doing +4, you do -4.
Does,
We're trying to get it alone, right?
yeah. But does it say +4 right now?
No, it's -4. Inverse operations.
So the inverse of minusing 4 is +4. So you just said it backwards. But we kind of knew what you were talking about. +4. Both sides. Now you don't do +4 inside the absolute values. Do it outside. Okay, you guys jumping in? Can I get your yellow papers? Or did she take them? She got them all? Okay, get a piece of paper out. You're just in time for this example. Okay, we're graphing inequalities. You can just share crayons with your neighbor because you really only need one crayon. By adding 4. Oh, add 4. Inequalities has something that we need to watch out for. When we add, do we need to flip the sign?
Yeah.
Ooh, I hear yeses and I hear no's.
I don't know. No.
Remember, sometimes inequalities we have to flip the sign. When does that happen? Okay, it has something to do with a negative. It's not adding, though. It's not subtracting. What?
Multiplying.
Division and multiplying. All right, this is something you have to watch out for. Thank you very much. If you multiply or divide both sides in the process of solving the problem, you have to flip the sign. So let's write a note to ourselves. We multiply or divide both sides. It's not just because there's a negative there. It's in the process of solving the problem you multiply or divide on both sides by, both sides, I didn't write that yet, by a negative. You flip the sign. So if it was a less than sign, it flips to a greater than sign. If it was a greater than sign, it flips to a less than sign. Okay, Danny, get a piece of paper out. Start with example 2, so you know how to do your homework. So, we added. Do we need to flip the sign since we added? No, so it will stay less than. And outside the absolute value is the +4. You don't add the 4 to the -1. That doesn't work. Outside the absolute value. Okay, there are 2 ways you could go about getting points for this. We could do an XY table, which we've talked about briefly. If you remember our absolute value lesson probably over a week ago. I want to use my bigger calculator. Let's use this one. We could put it into our calculator and get an XY table with a calculator. However, we have to know where the absolute value button is, which isn't really seen. How do I get this abs? You can see I already did it with the last class. How do I get abs? Do you remember how you do that? You exercise, yeah, 6-pack abs. That's how we do it. Exercise with our calculator. Danny? That was the secondary 3 stuff, yeah? Math! You go, if you don't know this and you plan on using a calculator for absolute value, you'll need to write it down. Math, and where do we go? Number. And you see abs? Yeah, abs is right there. Okay? Or, it's actually even faster to do it this way. I automatically see a horizontal shift and vertical shift. So you guys see that? Like we talked about when we were reviewing your homework. Horizontal shift and vertical shift. Which one's this one? Horizontal shift. And for horizontal shift, what do we think in our heads? Opposite. We did this at the beginning of class. Okay, and then we say the +4 is what type of shift? Vertical. We're glad Danny came to class. So, someone besides Danny, vertical shift, what word do we think in our heads? Same. Good job. And good job to Danny, too. Same. That's actually, guys, that's our vertex. So our vertex is opposite. So what number will we have in our vertex if we do opposite? +1, and then same, which would give us +4. And then we can use the slope to get more points. Slope and symmetry. What's the slope? Rise over run. What's the slope? 2 over +1. If you just stick a 1 under it, it keeps it +2. Okay, so we're ready to graph now. Using the rest of your space available, draw a nice large graph. Okay, since I know my vertex is 1, 4, I'm going to be in the positive realm. Also, something else I know, the slope is positive. Does a positive absolute value open up, or does it open down? Up, so we need space up above. So we can make our graph an upside down T, because we really only need the positive area. Okay, let's take it all the way up to 10. But we only need the positive area. Carlos, pick up your pencil, please, and start making your graph. This is our last graph for today, and then we'll be moving to arts and crafts time. Yes, we are literally doing arts and crafts for the next little while. Oops, that's not very evenly spaced. Let me try this again. Please label your graph. When labeling your graph, you should have X and Y, and then you should put tick marks and actually give those tick marks, a couple of them, some numbers so we know what you're counting by. I'm just going to go out to -5 and +5. Okay, the first thing to graph, on the last one we did the y-intercept, but on this one we know the vertex. So that would be our first thing to graph. Susanna, what was the vertex again? 1, 4, good. So we go from the origin, we go right 1, up 4. From that point we can use the slope, which is 2 over 1. Rise over run. Okay, Tristan W., can you explain how I move 2 from this point with rise over run? Which one comes first? Good. Up 2 and over. Does that mean right or left? Right 1. Good. So up 2, right 1. And guess what? Absolute value has symmetry. So we can actually go up 2 and left 1 as well, because it's symmetric around the vertex. And then keep going. Up another 2. 1, 2, right 1. My graph's slightly off because I'm on a weird angle. There we go. And up 2 more, right 1. Same with the other side. Go up 2, left 1. Up 2, left 1. Now before you draw a V through these, please show me, should this be solid or dashed? Solid or dashed? Show me, please. I don't want to hear it. I don't want to hear it. I want to see it. Solid or dashed? Looking at the inequality sign, solid or dashed? Solid or dashed? Thanks for showing me. Okay, those who came in late because you were in the computer lab, Where is it? That's the difference. So solid is when it's equal to, right? Not equal is dashed. So in this case, we are going to do dashed. Okay, so do a dashed V. You still need arrows on the end so that those go up and up forever. Is our graph done? Are we good?
No.
No. Why not? Parker, why not? Why is our graph not done?
Need the arrows.
I already have arrows. That's a good call though. We need arrows.
Need the color.
Shading. Crayon time. Remember we have to pick a test point. What is the most convenient test point to use? What's the most convenient test point to use?
0, 0.
That was our second most convenient. Number one most convenient is 0, 0. So put a dot there, label as 0, 0. We're trying to figure out if that point is true or false. Okay? We find that out by plugging in. Okay? So we can see this y is now going to be what number? 0 is less than 2 times absolute value. The x is what number?
2, 1.
No, our point was 0, 0. So the x is 0. Minus 1, absolute value, plus 4. So those from the computer lab, what we've done is we just took our absolute value function right here and replaced with our test point, which is y is 0 and x is 0, and I rewrote it. So you guys who came in, does that make sense? Okay, now we're trying to see is this true or false. So this one has a little more work than example 1 because we have to go back to order of operations. PEMDAS. Please excuse my dear Aunt Sally. What's the first thing in order of operations? Parentheses. But parentheses is actually standing for grouping symbols. Do we have grouping symbols here? Absolute value is in the family of grouping symbols. So we have to do inside first. 0 minus 1, which is -1. Okay? And these bars mean absolute value. We actually have to do that as well. Absolute value means the distance away from 0. Good. So absolute value can only be the positive form unless it's 0 itself. Right, Gerardo and Hakeem?
Right.
Hakeem, what's the absolute value of -1? It's the distance away from 0. How far away is -1 from 0? 1. Positive 1. Distance can only be measured in positive values, right? Okay, now we have multiplication and addition. Which comes first? And please excuse my dear Aunt Sally. Multiplication. 2 times 1 is just 2 plus 4, which is 6. Bring the 0 down. True or false? 0 is less than 6. True. Interesting. So where do we shade? Okay, there's either outside the V or inside the V. So we shade? But this is true. So we shade true points. So this point is outside. Grab your crayon, shade everything outside. And if you go over work like I have, just do it lightly. All the way up to that dotted line.
Make wings.
Okay? If that point had been false, where would we shade? Inside. Okay, so we just shade inside the V. Okay, I'm going to show you how to do one of the problems on the computer. Your assignment time only has 8 problems. It's on the computer. Okay, now when you use the program that 5 of you just registered for, you need to use Firefox. Internet Explorer doesn't really work. It kind of I don't know. It does weird things. You can't see everything. You need to use Firefox. Take it out. And you want? I haven't tried Chrome. You can try Chrome. I know Internet Explorer is a no-go. So, on my website, guess what? If you forget I'd appreciate it if you were listening. I would appreciate it if you were listening. Okay. On my website, if you forget the website, it's right here. MathXLforschool.com. MathXL, like extra large, forschool.com. Okay, so if you click on it, it takes you to a green page for a login. Here it comes, like that. That's the correct website. Now when you log in, I think I'm already logged in. Oh, but it's, okay. When you log in, it takes you to a page like this. You click on it. I kind of already logged in, so it's asking me to do stuff. Okay. And you come to your course home. You have 2 assignments. Currently, who's already finished the introduction? Raise that high if you finished introduction. Oh, not as many as last period. Okay, well, 2 of you, thank you. The rest of you need to finish. It is due by the 29th, which is tomorrow by 11:59 p.m. So the 5 of you who just registered today, you need to get that completed by 11:59 p.m. tomorrow. You can use our school internet here after school, in the morning, during lunch, if you don't have one at home. Yeah?
On the computer or on a piece of paper?
It's on the computer. The intro has you click around different places, gets used to typing in math and using the functions on the program. This next one is your new one, which is due on Thursday. Okay, key card, right? If you turn both these in on time, 5 in a row, this is 2 of them, 5 in a row, you get a key card. Okay, this one right here, 2 variable inequalities. If you click on it, it will open it up. Let me show you how to graph the first one. And if you also look here, because we're getting used to the program, I've opened it up. How many times can you do the problem? How many chances do you get? 3 chances, okay? So you just click on the question to get started. There are 8, I believe. Okay, I've already done this one, so let's see if it lets me go. Oh, I want to do a different one. Okay, I guess we'll go look at number 2. No, that's not the one I want to do. I want to show you a graphing one. Here's one. That one's okay. I wanted to show you how to graph, but since I've already done it, maybe that's the problem. Okay, well, I'll just incorrectly do it. How about that? Okay, if you've done the intro, what does this little search thing do up here? What? It zooms in. This is the one that's doing Thursday. Okay? And you need to graph this inequality. Okay, so look at the sign. Should it be solid or should it be dashed? Dash. Oh, right here you have the options between solid and dashed. So you click the dashed. And then it's not absolute value. Absolute value would be the V. Instead, we're going to use the line tool. Now this one you actually have to solve. Okay, so I get a minus divide by -5, which actually flips the sign. Anyway, the y-axis intercept would be at +4. And then the slope, I'm just doing it in my head, but you guys will have to do this by hand, -4x divided by 5, 5 over 4. If the slope is 5 over 4, that means we go up 5, so I'm at 4, I just clicked on it. I go up 5 and right 4. And see, it's starting to draw the line for you. If you click, then there's your dashed line. Now you have to decide where to fill. So where do we fill? I have a fill bucket. You only have to click one part. Okay? This one, hint, 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 the sign will flip because you divide by a negative. So say you work it out and you think, oh, this is the true section, you do that. Hit save. I haven't actually even thought about it. I just picked one. Let's see if we're right. Save. Oh, this save. This save. Check answer. Oh, sorry, it's not correct. And they'll give you some instructions. Probably because we filled in the wrong side. Okay, so you'll have up to 3 chances, but I just wanted to show you the tools of how you would graph it. Okay? Any questions about that? There are 8 problems. Yeah.
Let's do it next Tuesday or this Tuesday?
This Thursday by 11:59 p.m. Okay? All right, let me stop this.